Subject name Electrical Electronic Measurement, that is EEM. This is second year subject. Subject code is 22325, and topic of the today's lecture is DC ammeter. And myself DP Sonone from electrical department. Now, as the topic of the today's lecture is the DC ammeter. The DC ammeter is working on the principle of when current carrying conductor placed in the magnetic field, it experiences a force. By using this force, the DC ammeter, the pointer of the DC ammeter is exerted and it is deflect. On this principle, the DC ammeter is work. As the PMC galvanometer constitutes the basic movement of a DC ammeter, since the coil winding of the basic movement is small and light, it carries only very small amount of current. When we require to measure a large amount of current, it is necessary to bypass or minimize this large amount of current through the resistance. That resistance is known as the shunt resistance. Means the when we require large amount of current to be measured by this ammeter, at that time that current, which is large amount of current, is flowing through the source, that should be minimized, and that is minimized or the lowered by using the resistance which is connected across the moving meter. That resistance is known as a shunt resistance. The value of this shunt resistance can be achieved by the conventional calculation. Now, the schematic arrangement of connecting shunt resistance is, that is, the meter movement that is putting across the meter movement, that is the resistance of the meter movement is Rm. Rm is equal to internal resistance of the movement of the meter. Ish is the current flowing through the shunt resistance, that is shunt current, and Im is the full scale deflection of the movement of the meter, that is current flowing through the meter movement, and capital I is the total current that is flowing from the source, and that is the summation of the current flowing through the shunt resistance and current flowing through the meter, that is capital I is equal to full scale current of the ammeter plus current flowing through the shunt resistance, the current flowing through the shunt. Now, the value of shunt resistance can be calculated by since the shunt resistance is parallel with the meter movement, the voltage drop across the shunt and the movement of the meter will be the same, that is VSH will be equal to Vm. The VSH is the voltage drop across the shunt resistance, and Vm is the voltage drop across the meter resistance. At that time, VSH will be equal to the ISH into RSH, and Vm is equal to Im into Rm. That means this is the detailed voltage drop of the shunt resistance and meter resistance. Now, as ISH into RSH is equal to Im into Rm, at the time the RSH will be equal to Im into Rm divided by ISH. Now, putting the value of ISH, that is I is equal to Im I minus Im. Now, putting the value of ISH into above equation, that is RSH, that will be becomes RSH will be equal to Im into Rm divided by capital I minus Im. By putting the value of uh, this resistance, we can get particular amount of or lower the amount of current which will be flow through the meter movement. And for each required value of full scale meter current, we can determine the value of shunt resistance. Now here is the multi-range ammeter. As name tells us that the multi-range ammeter, the ammeter from which we can read the different amount of different ranges of current can be measured by using this ammeter, and the different amount of current can be measured by putting out the specific value of resistance across the meter or bypassing through that particular main current through the particular resistance and read the value of resistance. By changing the next value of different value of resistances, we can obtain the or lower the value of current which will be flow through the meter movement. The current ranges of the DC ammeter may be further extended by the number of turns number of shunts selected by the range switch. Such a meter is known as the multi-range ammeter, and these different resistances are connected through the shunt switch, and by that is a that is selector switch. The selector switch, when select the particular value of resistance, and that we can get the particular value of current which will be for the meter. Now, as in last slide, there is a four resistances are were connected, that is R1, R2, R3, R4, and which can be placed in the parallel with the meter movement to give the different current ranges. And switch S is a multi-positional switch having a low contact resistance and a high current carrying capacity, since its contacts are is in a series with the low resistances. That is the characteristics of the switch which is which we are going to use in the multi-range ammeter. That is it is having a low resistance and a high current capacity. The specific switch is that switch is known as the make before break type switch, which is used for the range changing of the resistances. This is a switch protect the meter from damage without shunt during the range of changing. As we know that the meter which is having low resistances, and when when large amount of current is will be flow through the DC ammeter, at that time it will get it will may damage the ammeter. So we have to use make before break type switch. If we use the ordinary switch, at that time this ordinary switch, when break the last resistance, at that time there will be no any shunt resistance, so it will may damage the DC ammeter. So we have to use the make before break type switch in the multi range ammeter. In case of a multi range make before break type switch, it makes the uh, makes the next resistance before taking last resistance. This is and last resistance, and by using this, it protects the ammeter from the damage. The maximum range of multi-range ammeter, that is the maximum range of current can we use by using multi-range ammeter is the 50 ampere, and the precaution to be taken while using multi-range ammeter is that we should have to read the maximum range of current, and after that step by step we can lower the value of current up to the good upscale reading is obtained. The as the different ranges of resistances are used in this type of, that is a multi-range ammeter type meter, so the value of this ammeter is increase. The cost of this ammeter is get will get increased due to the using different ranges of resistances. Now here is the Ayrton shunt or universal shunt type of meter, as the name tells us that. From the name, it is the inventor who have invent this type of meter. The difference is that in universal type meter and the multi-range meter is, it is the electron type meter is having high resistances are connected across the meter movement, the galvanometer. By using this we can increase the range without changing the damping. The multi-range ammeter that is used the technique are more accurate than those using make before break type switch, and also it will eliminate the possibility of meter without having shunt, which is the serious concern in the make before break type switch. That is the main advantages of using universal type switch. Now here is the selector switch changes the amount of resistance in the parallel with the rm, that is the meter resistance. The voltage drop across the parallel resistance is always equal when all resistances are placed in the parallel with the rm. Maximum sensitivity of the ammeter is reached when the total resistances, that is all resistance are placed with the meter movement. At that time maximum sensitivity of the meter can be achieved, that is when the total resistance are put across the meter movement. At that time the correct reading will be achieved. Now the maximum current can be uh, maximum rating of this type of, that is universal type of meter, can be used up to the 10 ampere. Now requirement of a shunt, the shunt which we are going to use to place across the meter, the material that having should have the different properties, that is that properties are the minimum thermodielectric voltage drop. The material should have the minimum thermodielectric voltage drop, that is having a soldering of a joint should not cause a voltage drop. By using this property, that there will not that particular meter will not read, that will be read accurate reading, because of there is no any voltage drop is occur. Second property of the shunt material is solderability. The resistance of different sizes and the values must be soldered within the minimum change in value. By using this property, different resistances and different values of resistances can be soldered by by minimum value of its resistance. When the different sizes of resistance are connected to the shunt across the meter, at that time it will not change the resistance of the meter. It will not change the resistance of the that connected resistance. Now precaution should be observed when using a ammeter for the measurement. When the particular meter is connected in the network or a circuit, at that time different precautions should be taken. The precaution are never connected a ammeter across the source of the EMF because its low resistance, it would draw the high current and destroy the movement. Always connect the ammeter in the series with a load capable of limiting the current. When ammeter going to use in a circuit, so at that time don't connect the ammeter directly to the circuit, because as the ammeter having low resistance, so large amount of current is flowing through the ammeter, at that time the ammeter may burn or destroy the, it may destroy the ammeter or damage the ammeter. So the that a large amount of current should be bypassed by using shunt. So this precaution should be taken when connecting the ammeter in the circuit. Second precaution is observe the correct polarity. If the reverse polarity causes the meter to deflect against the mechanical stopper, which may damage the pointer. When when a ammeter or a disammeter is connected in a circuit, at that time if the that should be connect proper polarity. If the polarity of the ammeter is get reversed, at that time it the the stopper may deflect against, and due to that it may damage the mechanical stopper, and which may also damage to the pointer and or a different parts of the ammeter. Third precaution is that is related to the multi-range meter. That is, first use the highest current range and then decrease the current range until the substantial deflection is obtained. To increase the accuracy, use of range that will be give the reading as near full scale as the possible. When we using the multi-range meter in a circuit, that time the multi-range meter should read first highest range. After that, step by step it should be decreased until the substantial position is obtained. Now here is the extending range of ammeter. The range of the ammeter can be extended by using the external shunt meter. At that time the the ammeter should be set to the lowest current range, and after that external shunt resistance is put across the ammeter. At that time we can get the extending range of ammeter. By obtaining this, there should be one no notice can be, that is, the range of the basic meter movement cannot be lowered. The range of the ammeter can be extended to the measure highest current values by using the external shunt connected to the meter basic movement. That the basic movement of the meter is that should be that is the lowest value of current range of that particular meter. This is the in this way the extending range of ammeter can be achieved. Thank you.